Okay, can you hear me well? Okay, great. So let's talk a little bit, briefly, a couple of minutes about the exam. I know it's still in your on your minds, and then we move on to the topic of today's lecture. So how did you do in the exam in general? You can turn on your mic if you want. You can tell me in the chat.
Professor,
Yeah.
hello.
Yes, Jad.
I think class did not do very good because first of all, I think exercises needed more time than we were given.
Yeah, yeah.
خاصة I think traverse was very even from the hint you would get lost. And, it would need it. I would say these would be like assignments. Hagman, two of them were Hagman level, and one was a bit easier.
لا Hangman level لا, right? So I disagree with you. They were just basically one function or two functions, or not like a full-fledged program. I understand that it was more difficult than the first one, but that's natural because of the material. Yeah, the material is more difficult for sure. In my opinion, it's of course you're stressed. You have to do this in 1 hour. It's this creates additional anxiety and causes you.
You are right, Professor. بس إنه this year is not like other years. أول شيء exam sequential إنه بفهم إنه يكون في كاميرا وبدك إياه proctor مع زوم proctor at WebEx و but is it possible the next time we don't do it so we can come back exercise?
Yeah, we've thought about this a little bit. So why are we doing them sequential? We're doing them sequential to avoid cheating, and unfortunately, we have to take this into consideration because you guys are online, you're on your own. We don't really know what's happening. Right?
But
so
the thing is, you are
control.
Yeah, TA.
Yeah.
Sorry. There's already a TA looking at us.
Yeah. So cheating doesn't mean, Jad. So cheating doesn't mean you have somebody. I mean, we don't control what you're doing. I mean, for instance, somebody could share a solution, with everybody in a group or something like this. We've seen things from last semester. I understand it's not ideal. I don't like it. I personally don't like it, and I feel it causes some issues. But it's just a measure for us to do to control cheating as much as possible. Now, here is what I want to tell you. We understand the exam is difficult. We understand that you probably did not do great in this one particularly, but I don't want you to panic or let this discourage you. We're putting these 3 exercises in the exam and the new assignment. I want you to solve them again. Take this as a learning opportunity. I'm sure it all boils down to the class average. So we don't expect that the class average for this exam would be very high, and that will allow us to kind of make sure that this grade doesn't affect you too much. Yeah. So don't worry if you have done, but take this as a learning experience. Try to solve these exercises again. We totally get that the exam is difficult, and we also get that you're under stress because of the online environment, etc. Yeah. So
could I say something else?
Yeah, sure. Go ahead.
وكمان moreover إنه usually if it was on campus the labs would be 3 hours I think.
Yeah.
And we use them more. No, I comprehend that they are 1 hour 30, but
yeah,
most of the time we are doing the and it's a bit very we are only coding alone and
so regarding the labs, we actually reduce them not because they're online, but we reduce them because we found that most people from previous years we're thinking the labs are just way too long, right? So it's not that because we moved online, we decided to experiment with a shorter lab because we feel it wasn't very effective, right? For 3 hours, most people just spend the 3 hours, and not get watched. So we wanted to try if, a shorter lab would help or not. And we'll definitely analyze this compared to, previous semesters and see if this is the right strategy. We totally understand. This is a very special semester. This is, for some of you, this may be your first course in the major, or if you're from outside the major, this is your first time you get exposed to something like this. And we totally understand that the situation is overwhelming for everyone. But try as much as you can, yeah, to kind of learn. I mean, the really important thing is that you learn, yeah, really. I mean, you will be surprised at the end with your grades, because if you do the effort and kind of really try and don't let one performance in one exam hold you back, things will be fine, yeah. So try to solve my take-home message is try to solve the 3 exercises from the exam again for the assignment, and you will see that they're not as difficult as the idea. It's not.
Okay.
We're looking at the solution. So I don't know what exactly you mean, Ali, by lenient, but we look at every line of code that you write. We'll look at it and we'll see if it makes sense. We have a very detailed rubric for the TAs to correct, where we actually ask them to read the program, make sure that it does what it's intended, it's logical. Even if the program doesn't finish, or if you have some lines of codes in the right direction, you will definitely get grades for it. Yeah, so you're not gonna get a very low grade just because your program wasn't working. Yeah, we totally understand this.
Professor?
Yeah.
So personally, wasn't, in terms of code, it wasn't something like that. The logic of the first question that got me off, not only could I not go to the next question when I didn't figure it out on time, but I had to stay there for 5 minutes to start. So that took away all my time, plus my internet going off and on. That really freaked out, and I think I really did bad.
Yeah. So I talked about this, Ramesh, on Friday. I gave you one advice. I told you, do not spend more than 20 minutes on any question. You have to be able to let go of a question, So I give you a guideline on how to really attack the exam. You look at the exercise, read it for a couple of minutes, try to, attempt an algorithm for 5 minutes, and then write code for the rest of the time. After 20 minutes pass, you move on to the next question. I understand this is really not the ideal way, right? I wish we could, allow you to go back and forth between the questions, but the problem is, right, this encourages cheating. We'll see for the final exam, maybe we'll like that. We always, at every exam, we always, bring this up to discussion, and I can promise you that we'll do that, but we'll at least be discussing. Yeah. Now let's move on. Don't again worry too much. Yes. I'll take one more question or comment, and then we move on. Yeah. Go ahead. Whoever's talking. Yeah.
They're like 6 سؤالين صغار. Is that okay?
What? I don't hear you.
2 questions بس كثير صغار.
Sure. Go ahead. يلا روي.
Thank you. أول ما كثير فهمت إنه letting us go to previous questions. How does that promote cheating or proctored? It's the same thing. Is it go back or we go forward?
Yeah, but it does, right? So basically, the idea that everybody has 20 minutes to do an exercise, and they can go back to it, right? And the questions are in random order, so everybody's seeing different questions. That reduces the the ability for students to kind of copy from each other. If you have the ability to go through the exam, you look at the questions, you could, for instance, solve one exercise and then share it with the other, right? So really, you could collaborate more, yeah.
If you could do that with going, with sequential exams, you could sequential. I mean it, Mom. How answer if we respond this lockdown ما بخلينا نعمل شيء.
Yeah, but
we're being proctored.
We're not talking about other devices. You could use other devices. You cannot control, what other devices have.
That's where that comes in.
Yeah.
Now?
Proctored,
You're
you were being
right, but the
yeah.
proctor cannot really see, you know, you might receive, you know, a message on your, you know, your WhatsApp, or you know, who knows, right? I mean, like, we cannot control. We're not, you know, we're not putting you in a closed lab and you don't have any, you know, connection to the output, right? So it just reduces.
He'd see me use my phone, Sheikh. The same thing.
Yeah, we could use another phone, right? I mean, there's the possibility we could go brainstorm about this forever. Yeah, there are possibilities.
Phone is our camera for the proctoring.
The final, you know, to put this to rest, right? It reduces for us. We see that it reduces the chances of cheating. Yeah, and I totally understand it's not convenient, but you know, this is what we believe. Yeah, and you just have to look at it. Again, we'll bring it up for discussion the next final exam, but I cannot guarantee you that we want to it. That's it. Yeah?
Okay, thank you. So my second question, but it's really
go ahead, Jawed.
Heck, it's curiosity. صاروا مثلا number of exercises in the like twice, 3 meet programs in every.
You're breaking a lot, so I'm not really comprehending what you're saying.
As this for example, previously it was mobile 3-4 programs per assignment. I'm also 9, 10, 12
previously
programs per assignment.
Previously in which you were talking about previous semesters, or you're talking about this, you know?
Yes, previous semesters.
No, that's not true. I have been teaching this course for I don't know, 3 years consecutively or 4 years, and the assignment is usually 10 to 12 questions. We usually reduce some, you know, some assignments are shorter if it's, you know, before an exam or after an exam, right? But in general, it's been very consistent. The idea of programming is really you have to write code. Yeah, you really have to, and we say this out loud from the beginning in the course, right? Description that you really, I mean, have to spend a lot of time writing. It's not about listening to slides and just you know, reading them. That's not programming. You really have to write code. That's how they develop the skill. You can, I mean, just plan it out. Don't leave it to the last minute. I understand that, you know, sometimes we cover the material on Friday and you don't have except the weekend, but try as much as you can to start on the assignment early on. As soon as it's posted, you know, start, you know, the questions you could solve and then move on like this. No, that's not true, Christina. That's what I'm saying as well. I don't know where you're getting this information from. The 4 times or the 3 times that I've taught this course, yeah, we've been giving exactly the same assignment style. So I don't think even, right, 2 questions per assignment this is pointless. Yeah, this is really useless. So then it's not mine. So I don't know which assignments you saw from which year, right? Check who was giving the course, and but the ones we've been giving, me and Dr. George, have been very consistent. Yeah, and it's really been consistent. Okay, let's move on. Let's talk about, you know, something more interesting now, and we're gonna talk about a new data structure, which is really cool. This is super simple and super cool. They're called dictionaries. So what is a dictionary? This is how it looks like. Yeah, Python dictionary is a sort of a table. It's a means or a data structure to allow you to store pairs of values, pairs of data. Yeah, to be more precise. I have 2 types of values or 2 types of data: key and value. Yeah, so it's similar to a table where you have, you know, the first column is a key, the second one is a value. Okay, so the value associated to key 1 is value 1, the value associated to key 2 is value 2, and so on. How do I define a dictionary in Python? I use the curly braces. Yeah, so the curly braces are used for defining dictionaries. Okay, for example, here's a dictionary that have, you know, 4 items, which is as follows. I have, you know, the name of a student and her or his grade. Okay, so basically I have Anna, she has a grade of B, John, he has a grade of A+, Dennis has a grade of A, and Kathy has a grade of A. Okay, so this is how it looks like, right? The braces tells me this is a dictionary, and then for each item in the dictionary, you have two values. The key, and then colon, and then the value. Yeah, so you have 4 items, and you have, each one is a pair, a key and a value. So here the keys are the names of the students, and the values are, their grades. Most of them are strings. You could combine. Some keys are, strings. So the keys could be strings, and the values could be integers, and so on. Let's try this out just to see what it looks like. Yeah. So I'm going to define grades as a dictionary. So now once I do these curly braces, it says, okay, now it knows that there is some place in memory which refers to as grades, and it's an empty dictionary. If I do length of grades, it will give me 0. Yeah, the dictionary is empty. Okay, let's put some values in grades. I'm gonna put Anna, okay, and B. Just one value for now. Right, so I'm saying, grades is equal to Anna. Okay. So now if I do length of grades, I should get 1. It has 1 item, right? Which contains of 2 values, the key and the value. Okay. So I can extend grades to John plus, and then Dennis A, and I have Katie okay. So now it has 4. Okay. Excellent. So as we said, this is the empty dictionary, and this is, key 1, value 1, key 2, value 2, key 3, value 3, and key 4. That's 4 items. Okay. So this is how it's going to look like in memory. It's going to be like a table like this, 2. Okay. So how do I find information in dictionaries, right? So do a dictionary lookup. So similar to indexing into a list, you look up by the key. So you say, okay, find me the grade of Anna or Dennis or John. Yeah. So you always look up in a dictionary, you give it the key, it gives you back the value. Yeah. So really, this is how it works. If the key is not found, it gives you an error. Let's see how we do this. So assume our grades, our dictionary is as shown here. And really, this is how I defined it. So it has 4 items. I can say grades of John, and that would really evaluate to A+. So it would return A+. And if I say grades of Sylvian, since Sylvan is not part of this, the keys in this dictionary, it gives you a key error. Okay, let me see. Adam. So Adam is saying, does the dictionary act like a list, as in we can append and remove from it? We'll see in a bit. Yes, you can. Yeah, you can append to it. You can write, but we'll see how. So we haven't talked about this particularly yet. I'm just talking about lookup for now. Okay, we'll talk about other operations in a bit. Okay, let's try this out. So I'm gonna do. I have grades like this. I'm gonna say, give me grades of Cali. I'm gonna say. Right? Before in a list, you would say grades of 0, grades of 1, right? Here you have to specify the key, which one you want to get the grade. And it gives me back an error. Key error, Katie. Why? Because it's an uppercase. Right? So I'm using lowercase, it has to be exact match. It gives me back A. Let's try another one. So grades of Anna. What does grades of Anna give me? Any thoughts? Gives me back B. Exactly. Okay, and so on. Okay. If I do grades of Ali, what does it give me? It gives me an error, a key error. Yeah, saying okay, Ali doesn't exist as part of the key. Exactly right. Okay. Right. So let's look at dictionary operations to answer Adam's question. Yeah. So kind of what are the operations, common operations we have in dictionary? Yeah. You can add an entry. You just say grades of Sylvan. So before we didn't have Sylvan, let's add him to the dictionary. So I just say grades of the key equal value. That will add Sylvan to the dictionary. Let's try it. Grades of Sylvan is equal to B, let's say. Now, if I look at grades, if I print grades, it has Anna, John, Dennis, Caddy, and now I appended Sylvan, okay, with his grade. Okay. So basically, this is what happens in memory. Yeah, I just add another row to the table. List of a key in a dictionary. So similar to what we did in lists or strings, I use the in operation. Okay, so when I say John in grades, why does it return true? Because John is part of the keys of the dictionary grades. And then when I say Daniel in grades, it looks at the keys, right? And obviously Daniel is not part of the, the keys of grades, and so it returns false. So in checks the keys. Yeah, you give it a key, and it checks whether it's part of the keys stored in the dictionary. Let's try it. So I can say, is Ali in grades? It should give me false because Ali is not part of grades. But if I ask John in grades, it should give me true because John is part of the keys of grades. Okay? Questions? How do I delete an entry? I just use the delete operation. Yeah, similar to like what we did with lists. Yeah, before you would give it the item you want to delete. Here you give it the the key. Yeah, so really that's what you're saying. So if I say delete grades of Anna, so Anna graduated or dropped the course. I don't want to keep track of her grades anymore. I just say delete grades of Anna. Now, if I print grades, it should print everything except Anna. So it has John, Dennis, Caddy, and Sid. Okay. Questions? Okay. Right. We can also get list of all keys and list of all values in a dictionary. Yeah. So when I do grades.keys, yeah, it's the name of the data, my dictionary. .keys, I call the method keys, right? So that's a method that takes no arguments, or a function that takes no arguments. It returns a list which contains all the keys inside the dictionary. Yeah, values would return a list with all the values. So I can separate the dictionary or break it down to two lists. One is a list of keys, one is the list of values. Let's try this out. So I can say grades.keys, and it should give me back, right, John, Dennis, Katie, and Sylvan, right, as a list, if you see. Yeah, so John, right, because we deleted already Anna, right? So I have John, Dennis, Katie, and Sylvan. And if I do grades.values, this is what gives me A plus A, and B. This one doesn't take an argument. Yeah, I'm just saying it's a function that doesn't take an argument. There's not another version of it that takes an argument. Yeah, this is just I'm trying to explain why we have the parenthesis. It's just a function, right? You're calling a method. We'll see this when we talk about classes at the end of the week. Okay. So, by the way, just to make the point clear, it's a list, no guaranteed order, in the sense, right, that it's not ordered alphabetically or anything, or, from smaller values to larger values. It's typically how the elements are inserted in the dictionary. Yeah, so really looks at how the elements are inserted in the dictionary or stored in the dictionary. Okay, same thing here for the values. There's no guarantee order. Okay. Just one last remark, and then we'll do a whole exercise on this. So we said in a dictionary there are two types of things, keys and values, two types of data, keys and values. The values can be any type. can be immutable and mutable data types. They can be duplicates. You know, dictionary values can be lists, even other dictionaries. Yeah, so you can have a dictionary. Let's do the following. You know, test dict. So let's say I'm gonna do a dictionary which has, you know, A as the key and, you know, 1 and 3 as the value. Okay, and then B and hello. It can be a mix of things, right? C and, you know, a list or a tuple which contains, you know, 1 and 3, and then D, and then could be also hello, right? So it could repeat even values. And that would work completely fine. If you do test dict, it just shows this, right? So what I'm trying to make, the point I'm trying to make is that the values can be anything. There's no restriction on all of them being integers. Or, you know, it could be one is a list, you know, one is a string, another is a tuple. You could repeat values, doesn't matter. Yeah. Now, what about keys? Keys are different. They have to be unique. That's the first thing. So you cannot repeat, you know, have two items inside the dictionary with the same key. So they have to be unique. They have to be immutable types. So basically integer, float, string, tuple, and boolean. That's it. Yeah. And be careful with the float type because you know, the way this is implemented is using hashing, and you know, so it might be not very exact. The same thing when we use floats and we equate, right? We always said, right, if you try to say a float value is equal to another float value, this might not always be precise because of how floats are stored internally in the computer. Yeah, they're not exact. Just a side remark. Okay, so let's try this out, right? Let's see if I can create, you know, if this is true. I'm gonna do Control C. Okay, here I'm gonna do, right. Let's try to define dictionary that actually has repeated values, right? Repeated keys, I mean. A and 1, B and 2, and let's say A and 3. It should complain immediately. Why? Because I'm repeating the key twice. Yeah, it did not complain. Let's see why. Yeah, it just kept that last one. Yeah, so basically it just ignored the first one. So it doesn't complain. It will just try to keep track one value per key. Right? It will not keep both values. Okay, let's try to do something with a non-mutable type. It keeps the last one, I guess. Right. You should, in general, you should not do this. You should avoid doing this. I'm just showing you an illustrative example. Dictionary, if you're going to use a dictionary, you have to always have the keys be unique. Yeah, so you cannot have multiple values per key. Yeah, that's what I'm trying to say. So you should not do what I'm doing right now to start with at all. Yeah, always avoid doing this. One key, basically one key existence. Yeah, so basically you should not duplicate keys inside a dictionary. Let's try with non-immutable type. So let's say, okay, you know, try it with a list, for instance, as a key. So I'm going to say D of 1 and 2 is equal to A, 1, 5. Lists, we remember that they are mutable. I can change their values. This should, yeah, unhashable type list, right? So it complains because, right, lists are not mutable. Okay. Just a side remark. You'll get used to this as we develop more exercises. Okay, so this dictionary, for instance, that you see at the bottom of the slides, how many elements does it have? Can anybody tell me? If I do length of D, what does it give me? Try to decipher it. Jana is saying 3, excellent. Here is the first element. That's the first element, okay? That's the second. And that's this. And it's really mixing values from different things, right? 3. Okay, so the first one has a key as an integer 4 and a value as a dictionary itself, with one element, which is a key of 1 and a value of 0. The second has a tuple as the key, and tuple are immutable, so I'm allowed to use it as a key, and has a value as a string. And the third has a key as a string and a value that is a list object. Okay, so this is really a weird dictionary. Typically in a real program, you would have a dictionary that usually the keys are one type, the values are one type, and they're consistent. Okay, questions? Excellent. Let's move on. So summary of the difference between lists and dictionaries, and then we'll do an exercise, on this. So let's see what is the difference between lists and dictionaries. When do I really use this and when do I use the other? So a list is an ordered sequence of elements. What does it mean ordered? It means, you have element at position 0, element at position 1, element at position 2, and so on. A dictionary matches keys to values. So you have pairs of, of values per item in a dictionary. One is the key and one is the value. I look up elements by an integer index in a list. I look up one item by another item, meaning I give a key, right? And it gives me back the value. Indices have an order. It starts from 0 all the way to length -1. Here, no order is guaranteed. Just basically, and you do look up based on keys. Index is an integer. Key, as we said, can be any immutable type. So it doesn't have to be, an integer. Okay. So I want you to do this exercise, and then we'll, take 2 minutes to 1 minute to solve it, and then we'll discuss your answers. Try to all of it, from A to Z, and then we'll take the answers. We'll do the answers together. So I have a dictionary which contains, basically codes for courses and their names. So try to execute all of these operations and tell me what the output will be, please. Once you're done, just let me know that you're done. I'm gonna prepare it. Sorry. Let's see. Let me just, yeah. Who's done? Anyone? I want you to do it by hand. Don't try it on your computer, because it helps with the, making sure that you understand the semantics of dictionary. You're still there, right? Done. Okay, good. So Suad is done. Okay, Jad as well. Perfect. Okay, Nasreen, Mahdi, Ali as well. Okay, Muhammad, Sergio, Daniel. Okay. Okay, Rawat send me a solution privately. We'll check it together. So, okay, let's give it a try. So I'm gonna do it one by one and see the output as we go. So the first thing is I'm doing D of 2, 5, 6 equal to. What does this do? Okay, Muhammad is also done. What does this do? When I do D of 2, 5, 6 equal to it adds to D. Exactly. So if I print D now, it has appended 2, 5, 6 as a key and algorithm as a value. Okay. When I do D of 2, 11, what does that give me? Math. Yeah, as a string, mathematics. Exactly, prints math. Do D of 2, 7, 5. Error, absolutely. All right, why? Because D of 275 is not part of this dictionary. It's not a key. Okay, length of D. 4, correct. 212 in D. False. Okay, correct. It's false because 212 is not part of the key. And now string databases in D dot values. Okay, true. It gives me a Boolean, and that's true because database is part of the value. So D dot values is going to return a list which contain all the values, and yes, database is one item there. D dot keys. What does it give me? A list, right, which contains 4 values: 200, 211, 277, and 256. Okay, and then if I do del of D of 211, what does it do? So this one. When I do delete, it deletes 211 and math. Exactly, Jet, right? So if I now print D, it has 3 items only, right? I removed D of 211 basically from D dot values. Finally, what does D dot values give me? A list, which is Python databases algorithm. Okay, perfect. All right, sounds great. Very good job, guys. This is what we get. Okay, so I'll discuss with you another exercise, and we're not going to do it today. Maybe you want to attempt it and try it, even though the code is on most posted on Moodle and on also in the slides. So you want to do the following. You want to write a program that analyzes the song lyrics. So I'll give it the song lyrics, right? Let's say, a song by your favorite singer. I don't know what your favorite singer is. Mine is Amy Winehouse. So I'll, give it lyrics of one song by Amy Winehouse, and it should do the following. It should try to figure out what is the frequency of every word inside this lyrics. Yeah, so I give it a string as an input, just representing the lyrics. For example, I want to show you an example here. Yeah. So something like this, right? So this is a song by Beatles called She Loves You. So I'm going to give it as an argument, the lyrics as a list of words. Yeah, just for simplicity. Of course, I can give it as a string, and then it transforms this into a list of words. Well, for now, we'll just assume that it's a list of words where, you know, every word in the lyric is just one item in this list. Okay, and what do I want to do? I want to take this, you know, list and be able to say, okay, this is the most frequent word. So in my example, it might be, you know, yeah, or you, right? So I want to count for every word that appears here in this list. How many times does it appear? So she, it appears, you know, 1, 2, 3. Count the number of times it appears in this list. Yeah, same thing for every one. And so it makes sense to use a dictionary. Why do I use a dictionary? Because I have two things I want to store. For every word, how many times it occurs. So it's like, you know, key, value, key, value. She, 10 times. Loves, you know, 3 times. So it's really like a lookup table. Yeah, it's very natural that I would use a dictionary. Also, the keys are strings, so immutable. So I'm allowed to use them as keys in a dictionary. Second thing is I don't want to store she multiple times, right? I want to say, okay, for every unique word in the lyrics, here is the number of times it occurs. So it makes perfect sense that I'm going to use a dictionary. Yeah, the dictionary is going to look like this. You know, for every word, the number of times the word appears. I'm going to run, you know, this just to show you what I mean by this, and then we'll talk about this, the code on Wednesday. So here is my lyrics. If I say, you know, I created a function called lyrics to frequency that takes this list, right? She loves you, which is the list of the words, and returns back a dictionary which says for every word how many times it occurred in the list. And so I'm gonna print this out. Just gonna comment this. All right. If I run it without saying how I did the code, right? If I run it, this is what it should give. And if you look at the output, it tells me she is 20, loves is 13, you is 36. Right? So every word, it tells you how many times it occurs. Okay, so once I have this dictionary, I can use it to find the word that occurs the most. So I loop over this guy and try to figure out, you know, or do something else. Yeah, we'll discuss, you know, ways of doing this. But what I want ideally is to say the following, right? Out of these, you know, key value pairs, which word do you think appears the most? If you look at this dictionary, if you have managed to build this dictionary, you know, which one do you think appears the most? So she appears 20, love appears 13, you 36, exactly. It's you and 36. So we'll want to write, you know, some code, some function that will go over these entries that I've created in the dictionary and be able to say, you know, what are the list of words that appear the most? Because it could be that, you know, there are 2 words that appear 36 times. Yeah. So then you should return, you know, what is the maximum frequency and the list of words that have this frequency. Okay. So that's the second thing we want to do. The third thing is we want to write a function that would, you know, tell me how many words, that will give me the words that occur at least X times. So I give it as X as an input, let's say, you know, 10, and it should just tell me, go over this dictionary or uses this dictionary to be able to tell me that, you know, basically she appears more than 10 times, loves appears more than 10 times, you appears more than 10 times, yeah appears more than 10 times, but think and you have and lost should not be part. It should print only, you know, the words that appear more than X times. And we'll see how to do this. Yeah, and I'll try to build a program that uses, you know, more like the same functions, more or less. There are various ways of doing this, but just, you know, I'll give you one solution of doing this. But you can try this out yourself as well, or even be encouraged to write.
Sorry, Professor.
Yeah.
I asked, no, is it possible to sort the dictionary?
And not really, right? You have to write probably a custom code. I have to double check this to see if there are, you know, certain libraries or operations. I don't remember, right? But
so like I need to append it to a list then to sort it, or I can just use sorted on dictionaries.
You can try. I don't recall honestly if they have a support for dictionary, right, and how, or sorting it. I can look this up quickly. Let me see.
I think there's something like import kaza kaza for it, but I don't know if we can do it with.
I don't understand exactly the semantic of how do I sort a dictionary, right? So what is the semantics? Is it based on the keys or based on the values or something like this, right? So
here it's more based on the values, I think.
Yeah, so
for example,
for sure you have,
U36.
Yeah, you have to write your own method to sort it, right, based on values. Right? But in principle, maybe for keys, there are some, an operation that can do sort based on keys. I'll look this up and we discuss it on Wednesday. Yeah, Jack. Okay.
Thank you.
You're welcome. Yeah, but we'll see how to do the. I understand why you're asking this question, because you wanted to say sort this dictionary based on values and then get me, the one with the on top. Yeah, but this is would not work for sure, right? But so you'd have to do something. You could loop, and keep track of the maximum value, or you could get the values, find the maximum using the maximum function, right? And then try to find all the words that have this value. We'll see various ways of doing this. Okay. All right, I'm done here. If you have questions about this, please let me know. Otherwise, we'll continue on Wednesday. We'll write this code on Wednesday. We'll look at another program, and then maybe do an exercise from the assignment if we have time. But you can start doing the assignment immediately. Yeah? So the assignment now, you're able to solve it entirely. All right. Questions? Okay, guys. Then we'll talk on Wednesday. Thank you.
Thank you.
Sure, yeah. Talk on Wednesday.
Have a good day.
You too. How do I stop recording?